Think about the last time you were stuck in a traffic jam, staring at a row of orange cones and a massive machine chewing up the asphalt. It's easy to feel frustrated, but if you look closer, you're witnessing one of the most complex, high-stakes engineering ballets on the planet. Building a highway isn't just pouring some road. It is a massive battle against physics, chemistry, and geography that has to be won before a single car can even turn a tire. Every great highway begins not with a bulldozer, but with a drill. Long before the construction crews arrive, geotechnical engineers take core samples of the earth. They need to know exactly what's underneath because the biggest enemy of a road isn't heavy trucks. It's the ground moving. If you build on soft clay or unstable silt, the weight of the road will cause it to sink and crack within months. Engineers have to design a foundation that is often much deeper and more complex than the road you actually see on top. Once the path is set, the earthwork phase begins. This is the heavy lifting. Massive scrapers and graders move millions of tons of dirt to create a level surface. But level is a dangerous word in highway construction. A perfectly flat road is a death trap because water would pool on the surface. Instead, every highway is designed with a subtle crown, a slight curve that forces water to run off into meticulously designed drainage systems. In the world of road building, water is the ultimate villain. If it gets under the pavement, it freezes, expands, and creates the potholes we all love to hate. Now, let's talk about the sandwich. A highway is built in layers. First, there's the subgrade, the native soil that has been compacted until it's as hard as rock. On top of that goes the subbase, usually made of crushed stone or gravel. This layer acts as both a structural support and a drainage blanket. Finally, we reach the surface, the part you drive on. This is where the great debate happens. Asphalt versus concrete. Asphalt is the flexible pavement. It's a mixture of stone, sand, and a sticky black binder called bitumen. It's faster to lay, cheaper to build, and offers a smoother, quieter ride. Because it's black, it absorbs heat, which helps melt snow in the winter. But asphalt is high maintenance. It wears down under heavy loads and needs to be resurfaced every 10 to 15 years. Then there's concrete, the rigid pavement. It's incredibly strong and can last 30 or 40 years without major repairs. It's the choice for heavy-duty interstate systems. However, it's much more expensive up front. And because it's rigid, it needs expansion joints to prevent it from cracking as it grows and shrinks with the temperature. That rhythmic thump-thump you hear while driving? That's the sound of your tires hitting those joints. The actual paving process is a marvel of precision. Modern paving machines are guided by GPS and 3D modeling. They can lay down miles of material with an accuracy of just a few millimeters. Behind the paver comes the rolling crew, using massive vibrating rollers to compress the material while it's still hot. If they don't get the density exactly right, the road will fail. It's a race against time and temperature. If the asphalt cools down too much before it's compacted, the job is ruined. But a highway is more than just a surface. It's a massive network of invisible safety features. Engineers design clear zones, the flat areas on the side of the road, so that if a driver swerves, they have space to recover without hitting a tree or a pole. They install rumble strips that use sound and vibration to wake up a drifting driver. Even the guardrails are masterpieces of kinetic engineering, designed to crumple and absorb the energy of a crash rather than piercing the vehicle. Construction today is also getting smarter. We are seeing the rise of self-healing asphalt that uses tiny steel fibers and induction heat to close cracks automatically. There are glow-in-the-dark road markings that charge during the day to save on street lighting costs. We are even experimenting with plastic roads that recycle thousands of tons of waste into the pavement mix. The next time you see that "Roadwork ahead" sign, try to look past the delay. Think about the thousands of tons of earth moved, the chemical precision of the binders, and the centuries of engineering knowledge beneath your wheels. We are building the arteries of our civilization, 1 millimeter at a time, creating a ribbon of stone and oil that connects us all. It's a brutal, noisy, and expensive process, but it's the only reason we can move as fast as we do. The highway isn't just a way to get from A to B. It's a monument to our refusal to let the terrain dictate where we go. When you're driving on a brand new, perfectly smooth stretch of pavement, do you ever stop to think about the layers of science